Okay, we're going to take probably about 20 minutes. Last period, I think we had like 15, 20 minutes left. We won't in here because I had to do some things in the back for lab. I'm going to have fourth period. But you guys will probably have 10, 15 minutes left. If you're going to be gone tomorrow, you want to take a quiz. You can. I had 3 people take it that are going to be taking the test tomorrow. If you don't think you're ready for it, that's fine. It's up to you. It's really up to you. I've got some of these to hand out. I guess some of you, these are the people who are going to be gone tomorrow. They're going to be testing. So try to come in the morning if you can. Probably took them, the 3 that took it, it took them about 15 minutes to take the quiz.
What about after school?
After school would be great. That would be a good time to do it as well.
What's all on the quiz?
The quiz for everybody, it'll be go over quantum numbers and the notes we took on quantum numbers, like principal quantum number, angular momentum quantum number, magnetic spin, what each represents, just specifics about each one and characteristics of each one. Any questions dealing with electrons, how many is in third shell, how many can fill the d orbitals or the d subshell. Those are the type of questions that will be on it. Plus, electron configuration, and we're going to finish up today. Brittany?
Okay, so a subshell is like the SPDF.
Right.
And then what is just a plain shell? Is that
Shell is just the energy level in which those subshells can be found. So shell 1, shell 2, shell 3 as you go out.
Oh, okay.
Those are your energy levels.
So what's the orbital?
The orbital is the specific location of the electrons. And they can only have 2 electrons in any orbital. So the S has 1 type of orbital. The P's have 3 orbitals, all different orientations. Yep. Okay? Yeah, it all kind of comes together as we try to work things together. I'm going to write out for the first one you had to do was strontium. I'm going to shorten these up. And you guys will, last class did a great job. They had some questions. They started figuring out how to use the periodic table as kind of a map of how to get there and not have to start at hydrogen each time. You definitely not going to start at hydrogen each time, but it's kind of like baby steps. It's kind of like we have to know how it starts, how it proceeds, and go down so far, and then at that point, we should be able to not have to start at hydrogen each time. Okay, we can start at a different point, and you'll understand what that is with the 2 examples that we'll show today. So strontium is in the 5th row, and so what we'll do is give you the configuration for it. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Any questions on that?
What if you tried the shortcut?
Right, you're ahead of us, Jared, so that's
I don't think
okay.
I did it right.
Well, but I will give the shortcut. I will give the, what we call shorthand or noble gas configuration is with the actual term. Adam?
Strontium stops at 5s2.
Yep, it starts on the 5th row, and it's the 2nd element in the S's. So the rubidium would be 5s1, and strontium is 1 more electron, would be 5s2. If we add everything up, the numbers up, we'll come up with the number for strontium, and it's 38. So if we add all those up, we get 38. Now I'm going to show you the shorthand, or the noble gas configuration for this. So what we do, we have to find a place that is consistently starts each element out. And we always want to pick a noble gas. Because the noble gas is the end of the row. The noble gas, we'll find out later, noble gases have a full outer shell of 8. the most any element can have in its outermost energy level is 8. It's kind of like music. How many notes are in a scale?
8.
8. Usually. 8. So if you go up an octave, you go up, you know, that next one, a higher note, C higher. Right? So electrons, the most you can have is 8. You can't have any more than 8. When you say, well, the third shell holds 18. Yes, it does. But it's not always going to be considered the outer shell. Because we have S's that are going to start to fill before the D's are filled. So you'll find out that is an important concept to understand and know when we get into stable elements, unstable elements, how many electrons need to be gained or lost by an atom. And all atoms will tend to want to become stable or lower energy, and that's when they have 8 electrons in their outer shell. So not all these elements in their pure form are stable. All right. So what we're going to do, what we're going to do is we're going to look at the noble gas in the period that is in the period above the element that we are finding electron configuration for. So we locate strontium, we go to the row above it, and we go all the way to the end, and we find out what noble gas we would write down as our starting point. Because we kind of got to write the location of what we need to start with. So we go up the row above it, and we find out it's krypton. So this is what's called the noble gas configuration. Now, I did not write out the orbital notation for this because it becomes really tough to kind of figure out. It's much better to use a noble gas configuration or a shorter method to show it. So again, we put krypton. So again, we've got strontium. And then what we're going to do is we'll go krypton and in brackets. There's where we're starting. It's kind of like if you get on the Google Maps and you go, I don't want to know how to get from here to Omaha, but once I get in Omaha, I know I need to figure out where to go, so I'm just going to put coordinates Omaha and then starting at a certain point and then getting there. So that's kind of what we're doing. We're kind of like, we know how to get here, we just have to finish it. So then if you count down the periods, when you do this, the periods indicate the shell the S's start on. My pin's off, so. But anyway, we're down here. And let's say that this is 1, 2, 3, 4, 5. We're in the 5th row where that starts, and we need to go right here. Right? So what we'll do is that's where we're starting right here, because the krypton's right over here. So we're going to start at the 5s, so we'll go 5s 2, and then that's all we'll have to write for it. Is that easier? Yeah. But you have to know where you start, and so that's kind of what we go through progression doing that. So the period tells you the S's and P's. The periods tell you the S's and P's. So all you have to do is count down if you want to know where to start. And guess what? S's always start each electron configuration. S's are always our starting point. And then it could be D's next if we go down far enough. Or sometimes it's P's. Like if it's the periods 2 and 3, then P's would follow. Because there's no D's that we have to go through. But once we get into the 4th row across, then we start getting into D's. And we'll get to one of those with molybdenum. Okay. So then what we do to do the orbital notation, it would look like this. that would be the noble gas configuration for strontium. Go ahead and do the noble gas configuration for your answer for molybdenum, and then I'll go ahead and write up here what molybdenum, that's the one you had to do, right? Okay, I'll go ahead and write up molybdenum up here. Okay? So I didn't have enough room to write that down, so I just kind of included it underneath. Any questions on that, molybdenum? It's kind of got a pattern. You kind of see the pattern. It goes S's, then D's, and P's. And the D's are one behind when you get into the D's. So if you would do the noble gas configuration for that, you would locate, we still use krypton, so it would be Kr. It would be 5s2, 4d4. And then, if we would do the lines underneath, it would look, the orbital notations, how they fill in, would look like this, according to Hund's rule, and how we need to fill them in. Any questions on that? Those, yes?
Why would it be 40?
Okay, so we go back to how they fill up. We fill up this shell first, so this is 1s2. Then we fill up this shell, which is 2s2, 2p6. We start filling this shell up. And that shell has the S's, P's, and D's. So we go 3s2, 3p6. And then where we're at this location we're at 4s2 next, right? So we go 3p6, and now we're at 4s2. So we have to come out here, out to the fourth shell, to fill the S's out. Then when the S's are filled, we go back and start filling the D's. So if you look at when the D's are filled, they're always filled, an inner shell filled. Starts to fill before an outer shell would completely start to fill. So we always go to the previous shell when we do the D's, because those are the ones that are going to start to fill. We can't say 5D because the fourth shell, the D's have not been even placed. Okay. All right. I hope that explained it, but that's kind of the way the progression has to go. That's what they tell me. Right? It's a theory, kind of how things work. And it's been supported. I mean, it's not like it hasn't ever been supported, but, you know, there's probably some things that are kind of, you know, need to be figured out yet. It's not just perfect. Yes?
Why did you start at Krypton?
Okay, so then what I do, I find where molybdenum is, and I need a starting point. So my starting point is always going to be in the noble gas in the row above it, in the period above it.
Okay.
So I just go up, and I go to the period above it, and I say, okay, that's going to be my starting point, and then that puts me on the same row that my element's on. So now I'm starting on the fifth row, if that's where it's at, to do my element. All right, so I'm going to have you do two. I'm going to have you do the noble gas configuration for these. And just remember, when you do them, if you count down the periods, that is your S's that you start on, the shell of the S's you start on. Okay? And then depending upon how far you travel across that period will indicate what your electron configuration is. So I'm going to give you two to do. The two that I'm going to pick out, I don't want to be repetitive on a quiz or lab that you have to do. So I'm going to have you do Cobalt, CO, and Antimony, SB. Yeah, SB. Cobalt and antimony. Yeah, you all right? Hello? Okay. All right, so we're going to go ahead and do these. So cobalt, we find out what row it's in. And cobalt is in the 4th period. So we find argon, which is in the noble gas in the period above it. We write argon, and then we pick up from argon. But this is the 4th period, so we go 4s2, and then we count over 1, 2, 3, 4, 5, 6, 7. 3d7. Then when we do our lines underneath, the D's have 5 possible orientations, or orbitals. So we'll fill them in one at a time until we have to pair them up. And that would be your answer for cobalt. Okay, and the last question I'll ask you on the assignment for today is how many electrons are in the outer shell? So how many electrons are in the outer shell? Now, some people think this is biggest energy, the 3D is the biggest energy, so that's the outer shell. But the outer shell would be the biggest number that would be location farthest out.
So we always go with the biggest number?
Biggest number indicates the farthest shell out. So there would be 2 in that. So there would be 2 electrons in the outer shell. Okay? Antimony is in the next row down. So you'd write krypton. And you go 5s2, 4d10, 5p3. Any questions on that? The S's and P's are the same level, same shell they're being filled. So then when we do the orbital notations underneath, these are filled, so they don't have up and down arrows. And then the last one would be like that. Any questions on that?
So there's 3 electrons in the outer shell?
Nope. There would be 5.
5.
Uh-huh.
Okay, so everything's filled, you don't have to write it as you just say it's filled.
Yeah, I'm not going to make you fill it in. If you want to do that, that's fine. I understand that. That's a pretty easy way to do it instead of putting all the arrows in, you know. Yes, Kaylee?
So, it would be 5 in the other shell?
Yeah, because anything in the 5th shell. So some of you are thinking subshell, and we always want to look at shell, and the biggest and the highest or farthest energy level out is the 5th shell. So it has 2 in the S subshell in the 5th shell.
Oh, so you add, okay.
So you add them up.
I get it now.
Okay.
Yeah.
I was just about to ask that.
Yeah, but you got to be careful because you're saying, well, there's only 3. Well, these 2 are in there too.
Okay.
So there's 5 in the outer shell. If you notice, when S's and P's, when they're all filled, that adds up to 8. So that's the most you can have in the outer shell. So if we would go all the way to the end of noble gas, it would be a 5p6. If we go all the way to xenon, it'd be 5p6. And then when you count them, it'd be 2 and 6 is 8. And then we start over. We go to the next higher shell after that. Brittany, you got a question?
No.
Any comments, Adam?
So like the most a shell can have is 18.
No. The most a shell can have of the ones we have available is 32. It'd be the 4th shell.
But then you keep moving to the next one every time.
Right. Right. But the 4th shell could get 32 when we get in the Fs. We're not going to do any Fs. But if we would go through the Fs, I'd add 14 more to the 4th shell. So if we would go, Adam, we would go all the way through here, which are the F's, and then we get into these numbers here, 72, and these numbers here. We now have 32 in the fourth shell. But that's not going to be the outer shell, because what you have is fifth and sixth levels starting to fill before the fourth is filled. Okay? Alright, these are the ones I'm going to give you to do. You do them on a separate sheet of paper. You can do the shorthand. Niobium, NB, bromine, Br, cesium, CS, rhodium, and silver.
Do you want us to do it in a shorthand version then?
Yes, I would prefer you do it in there. It makes it a lot
Do we
easier.
have to write it out all on the quiz? Like,
No.
we can just do the shorthand.
Noble, I call it the shorthand. The book doesn't call it the shorthand. The book calls it the noble gas configuration because you started a noble gas.
But that's what we're doing on the quiz.
Yeah, I would prefer you would do that every time you do it, because now I might have you do one, like on a test or quiz, but you wouldn't have to go very far. You might have to go like to phosphorus and then start with hydrogen.
Okay.
You know, something like that. But as we get farther down, you would not have to go any farther. Yeah, I thought you guys would like that.
Yeah.
It's kind of like we have to start at the beginning, and then you're like, God, I don't want to do all this. This is, and then you go, all right, here, noble gas. I know where I'm at and how I got there. So.